Hello academics, today we will be learning about instantaneous rate of change, also known as IROC. This is very similar to what we had previously learned in the past video, which is AROC, which gives us the formula of f of b minus f of a over b minus a, but it's also another version of just rise over run, right? And so today, that represents on this graph, let's say these 2 points, it represents the average rate of change of these 2 points, in between these 2 points. But what if we found a way to kind of tweak this to get the instantaneous rate of change? Of course we can do it with derivatives, but we haven't learned that quite yet. So how can we do that for now, in the scope of this course? Well, but what if we could apply that to this course? Well, let's take a deeper look into that. So we started off with this right here. And so that gives us the rate of change between these 2 points. But what if we brought them a bit closer? Could we get to just 1 point? Like, what if we did right here and right here? And then we got this rate of change right there. Well, that's close, but what if we get even closer? Because we can see we're still clipping the parabola a little. We want it to only touch at 1 point. What if we got so close that it almost looked like just 1 point with the tangent crossing it just like that? Well, that's what we're going to do today in this next example. We're going to see that if we can convert AROC into IROC. Well, to do that, we're going to use the equation that the average rate of change is rise over run on this difference. But for instantaneous, we're going to say it's the same thing if we bring the limit of the change in x to 0 on the rise over run. What if we approached the difference in x represents the distance in these points on this graph? It's that right there. What if we brought it so close that it almost looked like there was none? Well, that's what we'll do in this next example. And so to simulate that, we are going to pick 2 points, let's say 3 and 3.00001, right? Or let's just do 3 zeros to keep it simple, right? What is the average rate of change between these points? It'll be quite similar to just the instantaneous rate of change at the point 3. And so let's use the equation f of t equals 150 times 3 to the power of t over 10. This is just an exponential equation. It grows exponentially. But for this, let's do the instantaneous rate of change at 3 seconds. And so to do that, we're going to first write out the equation. So 3 and then 3.1231. And we're going to do, that's equal to f of 3.0 minus f of 3, and then 3.0001 minus 3. And that, of course, is pulled from our f of b minus f of a over b minus a. And so let's just do this on the calculator real quick. So that is 208.56066668 minus 208.5583755 over 3.001 minus 3. And that just gives us 22.913 units per second. It's important to add the units to this because it is an equation that has some, since we specified their seconds. But yeah, so that represents the instantaneous rate of change at 3 seconds, quote unquote, because of course it's just an estimation because we didn't do the derivative. But I'm sure if we did do the derivative, it would be quite close to this. But yeah, so that's it for the lesson today. Please let me know in the comments if you have any questions or concerns. But yeah, thank you for listening, and I hope to see you in the next video. Thank you.